Snowfall in the northeast, Arctic air pushing south, lake effect snow bands setting up across the Great Lakes, wind chills dropping to dangerous levels. That is the weather pattern taking shape over the next week to 10 days. I've examined the latest model runs from the National Weather Service, the European Center, and the North American mesoscale model. And what we're seeing is a significant pattern shift that's going to bring winter weather to a large portion of the United States and Canada. Not clickbait, not hype, just the facts based on current atmospheric conditions. Let us start with what's happening right now, because understanding the current setup helps explain what's coming. Across the western United States, particularly Idaho and parts of the northern Rockies, temperatures have been running well above normal. Some areas are seeing their warmest winter in over a century. That warm air mass has been persistent. Meanwhile, the truly cold air, the Arctic air that typically moderates somewhat before reaching the lower 48, has been bottled up in Alaska. And when I say cold, I mean dangerously cold. Northern Alaska is seeing wind chills of 66 degrees below zero. Temperature anomalies in parts of Alaska are running 50 degrees below normal. That's an extreme departure from average, and that cold air is about to redistribute itself. The mechanism driving this change is the tropospheric polar vortex. This is different from the stratospheric polar vortex that sometimes makes headlines. The tropospheric vortex is a feature in the lower atmosphere, typically between the surface and about 30,000 feet. Right now, that vortex is centered over Alaska, but the models show it migrating eastward over the next week. By January 20th, which is exactly 1 week from today, the tropospheric polar vortex will be positioned over Hudson Bay in eastern Canada. When that happens, Hudson Bay becomes our primary cold air source. The clockwise flow around high-pressure systems to the west and the counterclockwise flow around that polar vortex will funnel Arctic air directly into the central and eastern United States. This is a classic mid-winter pattern, and it is setting up right on schedule for the climatologically coldest period of the year. Now, before we get to that major Arctic outbreak, we have some active weather to deal with over the next several days. A winter storm is currently moving through southeastern Canada, affecting Ontario and Quebec. This system is not producing blockbuster snowfall totals. We're not talking about 2 feet of snow, but it is creating hazardous travel conditions, snow-covered roads, reduced visibility, slippery conditions, widespread snowfall totals of 3 to 5 inches across much of southern Ontario and southern Quebec, some locally higher amounts in favorable terrain. That system is also interacting with the Great Lakes, and this is where things get interesting for portions of Michigan, Indiana, Pennsylvania, and New York. Lake effect snow is setting up along the traditional snow belts, western lower Michigan, northwest Indiana, the south shore of Lake Erie affecting the Cleveland area and continuing into Erie, Pennsylvania. The eastern shores of Lake Ontario, particularly the Tug Hill Plateau east of Lake Ontario and western New York. These are the areas that consistently see lake effect snow when the wind direction is right and when we have sufficient temperature contrast between the relatively warm lake waters and the cold air passing over them. Both of those conditions are in place. Going into Wednesday morning, lake effect snow bands will intensify. Some of these bands will be quite narrow, maybe only 10 to 15 miles wide. But within those bands, snowfall rates could reach 1 to 2 inches per hour. If you lay in one of those bands for 6 to 8 hours, you could see significant accumulation. 12 to 15 inches is possible in the most persistent bands, particularly in western lower Michigan and northwest Indiana. The Tug Hill Plateau in New York, which is well known for lake effect snow, could also see heavy totals. This area benefits from its elevation and its position relative to Lake Ontario. When the wind comes out of the west or northwest, that plateau acts like a snow machine. 15 to 20 inches is not out of the question there. For areas outside these narrow bands, accumulations will be much less, maybe a few inches, maybe just snow showers that don't amount to much. That's the nature of lake effect snow. Very localized, very dependent on your exact location. By Thursday, we are going to see the snow line push farther south than many people might expect. Not a major snowstorm, not a nor'easter, but snow showers reaching into parts of North Carolina, including the Raleigh area and possibly Charlotte, parts of Virginia Beach, Delaware, Atlantic City, New Jersey. These southern areas want to see significant accumulation, maybe a dusting, maybe an inch in spots, but it's unusual to see snow showers that far south, even in January. It speaks to how far this Arctic air mass is going to push. After that, Thursday system moves offshore, attention turns to the weekend and early next week. This is when the real cold arrives. Let us talk about temperature departures from normal. By Sunday, January 18th, temperature anomalies across the Midwest, the Great Lakes, and the Ohio Valley could easily be running 20 degrees below normal. Some locations could see departures of 25 to 30 degrees below normal. What does that mean in practical terms? Let us take Chicago as an example. The normal high for mid-January in Chicago is around 30 degrees Fahrenheit, about -1 Celsius. The normal low is around 15 degrees Fahrenheit, about -9 Celsius. If we re-running 20 to 25 degrees below normal, we re-looking at highs struggling to reach 5 to 10 degrees above zero. Lows could drop below zero, potentially to -5 or -10 Fahrenheit. And that S before wind chill. Wind chill is the apparent temperature your skin feels when wind is factored in. Moving air removes heat from your body more efficiently than still air. When you have temperatures in the single digits and winds of 15 to 25 miles per hour, wind chills can drop to dangerous levels. For Sunday morning across Minnesota and northern Wisconsin, wind chills could range from 5 below zero to 15 below zero Fahrenheit. That S -20 to -26 Celsius. At those wind chills, frostbite can occur on exposed skin in less than 30 minutes. If you're heading outdoors, you need to bundle up. Multiple layers. Cover all exposed skin. Limit time outside. The Chicago Bears are playing the Los Angeles Rams on Sunday at Soldier Field. Game time temperatures around -5 Fahrenheit, about -20 Celsius. Wind chills near zero. If you're re-attending that game, dress appropriately. This is not the time to show team spirit in just a jersey. Thermal underwear, insulated jacket, winter hat, gloves, boots, all of it. This cold air will stick around into early next week. Monday and Tuesday of next week, the cold remains entrenched across the northern tier states. The Gulf Coast will see cooler temperatures as well, though not the extreme cold that the northern states will experience. The Arctic air mass will be centered too far north to bring truly dangerous cold to places like Louisiana, Mississippi, and Alabama, but temperatures will be below normal, probably more noticeable because it's been so mild recently. Now, let's look beyond next week. Let's talk about the last week of January, roughly January 24th through January 31st. Several atmospheric patterns are aligning that suggest an active period for winter weather, particularly in the northern and eastern United States. First, the Madden-Julian Oscillation, or MJO. This is a pattern of enhanced tropical convection that moves eastward around the globe roughly every 30 to 60 days. The MJO has different phases, numbered 1 through 8, based on where that enhanced convection is located. Different phases tend to favor different weather patterns in the mid-latitudes. The MJO is currently moving from phase 7 into phase 8, and it's amplifying. Phases 7, 8, 1, and 2 tend to favor colder and more active weather patterns across North America during winter. When the MJO is strong in these phases, we often see troughs in the eastern United States and ridges in the western United States or Alaska. That supports cold airflow into the lower 48. Second, we have the tropospheric polar vortex positioned over Hudson Bay, as I mentioned earlier. That keeps the cold air source close to the United States. It doesn't have to travel as far. It doesn't moderate as much. Third, there is a strong Kelvin wave moving across the Pacific Ocean from west to east. A Kelvin wave is a type of oceanic wave that can influence atmospheric circulation. This particular wave is likely to activate the subtropical jet stream as it approaches North America. The subtropical jet has been largely absent this winter. Most of our storm systems have been coming down from Canada on the polar jet. The polar jet tends to be farther north and often produces dry, cold systems. The subtropical jet, which flows farther south across the southern United States, taps into moisture from the Gulf of Mexico and the Pacific. When the subtropical jet becomes active, we tend to see more organized storm systems with heavier precipitation. If we get phasing between the polar jet and the subtropical jet, where energy from both jets comes together, we can get significant winter storms. The pattern late in January suggests that phasing is possible. Looking at the extended range ensemble guidance from both the European Center and the Global Forecast System, there are suggestions of below normal temperatures across much of the eastern two-thirds of the United States between January 24th and 31st. The coldest anomalies appear to be across the northern states, from the northern plains through the Great Lakes and into the northeast. There are also suggestions of above-normal precipitation across parts of the Central Plains, the Ohio Valley, the Midwest, and into the Mid-Atlantic and Northeast. When you have above-normal precipitation and below-normal temperatures in January, that typically means snow. I want to be clear about uncertainty here. We're relooking at an extended range forecast. This is 10 to 18 days out. Models have skill at this range for large-scale patterns, but they don't have skill for specific details. I can tell you on January 13th whether you're going to get 6 inches of snow on January 27th. The models change too much day to day. What I can tell you is the pattern looks favorable for winter weather during that period. If you live in the Ohio Valley, the Midwest, the Mid-Atlantic, or the Northeast, it would be reasonable to expect the possibility of accumulating snow events during the last week of January. For those in the Central Plains, the Ohio Valley, and the Midwest, this could be your best chance this winter for a significant snow event. The pattern has been unfavorable for much of the winter, too progressive, systems moving through too quickly without time to develop. But late January could be different. The Interstate 95 corridor from Washington, D.C. through Philadelphia, New York City, and Boston has seen very little snow this winter. December was mild, early January has been quiet, but the late January pattern could change that. Again, no guarantees, but the potential exists. Now, I know some of you are frustrated. You've been waiting for snow. You haven't seen a significant snowstorm in 2 years. The winter has been disappointing. I understand that. Weather patterns don't always cooperate with what we want, but this is why we watch the trends. This is why we look at the extended range models, because patterns do eventually change. Let me address something I see in the weather forecasting community and in comments from viewers. There's often a tendency to overhype or underhype winter weather. Some forecasters lean towards sensationalism to get views. Others downplay everything to avoid being wrong. Neither approach serves you well. My approach is to present the data as objectively as possible. When models show a strong signal for significant weather, I'll tell you that. When models show uncertainty or a lack of significant weather, I'll tell you that too. Right now, for the next several days, we have high confidence in lake effect snow, high confidence in an Arctic blast, and lower confidence in organized winter storms. For late January, we have moderate confidence in a favorable pattern for winter weather, but low confidence in specifics. That's honest forecasting, and it is based on understanding model strengths and limitations. Let me spend a moment on model interpretation because this is important for understanding weather forecasts. Weather models are computer programs that solve complex mathematical equations representing the atmosphere. They take current observations, the initial conditions, and they project forward in time based on the laws of physics. But the atmosphere is chaotic. Small errors in the initial conditions can grow over time. That's why models have different levels of skill at different time ranges. For the next 1 to 3 days, models are generally quite accurate. They can pinpoint the timing and intensity of weather systems reasonably well. For days 4 through 7, models are still useful, but uncertainty increases. The overall pattern is usually well predicted, but details can change. Beyond day 7, we were looking at pattern forecasts rather than specific event forecasts. We can see whether a trough or ridge is likely. We can see whether temperatures will be above or below normal. But we can reliably predict that it will snow 6 inches in your town on day 10. Some models are better for certain applications. The high-resolution rapid refresh, or HRR, updates every hour and provides high spatial resolution. It is excellent for nowcasting and for the next 12 to 18 hours, but it only runs out to 48 hours, so it is not useful for extended range forecasting. The North American Mesoscale Model, or NAM, provides good detail for the next 3 days. It is particularly good for lake effect snow and other mesoscale features. The Global Forecast System, or GFS, runs out to 16 days. It is useful for looking at extended range patterns, but its resolution is coarser, so it doesn't capture small-scale features as well. The European Center model, often called the ECMWF, is generally considered the most accurate global model. It has better resolution than the GFS and better physics. For medium-range forecasts, days 3 through 10, the European model often outperforms other models. All of these models also have ensemble versions. An ensemble is a collection of model runs with slightly different initial conditions or slightly different physics. By running many versions, we can assess uncertainty. If all ensemble members show the same solution, we have high confidence. If ensemble members show a wide spread of solutions, we have low confidence. For the Arctic blast this weekend, ensemble members are tightly clustered. High confidence. For potential winter storms late in January, ensemble members show more spread. Lower confidence, but enough of a signal to warrant monitoring. Let me talk about preparation because that's ultimately what matters. Forecasts are only useful if they lead to appropriate action. For the lake effect snow over the next few days, if you in western lower Michigan, northwest Indiana, the south shore of Lake Erie, or western New York, prepare for the possibility of heavy snow in localized areas. If you in one of those narrow lake effect bands, travel could become very difficult very quickly. Have supplies in your vehicle if you must travel. Blanket, flashlight, extra food and water, phone charger. If you don't need to travel during heavy snow, don T. For those of you who handle snow removal, whether for your own property or professionally, don T. Try to clear everything at once if snow is still falling heavily. You will exhaust yourself. Wait for breaks in the snowfall. Pace yourself. And if you use a snowblower, make sure it's in good working order before the snow starts. Check the oil. Make sure you have fresh gasoline. Clear the chute so it doesn't clog. For the Arctic cold this weekend and early next week, prepare your home. If you have pipes in unheated areas, let faucets drip to prevent freezing. Open cabinet doors under sinks to allow warm air to circulate around pipes. If you have a furnace, make sure it's working properly. Change the filter if needed. Stock up on any necessary supplies so you don't have to make multiple trips out in dangerous cold. If you need to be outside for extended periods, dress in layers. Start with a moisture-wicking base layer. Add insulating layers like fleece or down. Finish with a windproof and waterproof outer layer. Cover your head. You lose a significant amount of body heat through your head. Wear insulated gloves or mittens. Mittens are warmer than gloves because your fingers share warmth. Wear insulated waterproof boots. Cold feet make everything worse. Limit your time outdoors. Frostbite can occur quickly when wind chills drop below zero. Watch for signs of frostbite. Numbness, white or grayish skin, firm or waxy skin texture. If you suspect frostbite, get indoors and warm the affected area gradually. Don T. Use direct heat like a heating pad or fireplace. Use warm water about 100 to 105 degrees Fahrenheit. Watch for signs of hypothermia, shivering, slurred speech, confusion, drowsiness, lack of coordination. Hypothermia is a medical emergency. Call for help and move the person indoors if possible. Check on elderly neighbors and relatives. Older adults are more vulnerable to extreme cold. Make sure they have adequate heat and supplies. Offer to help with tasks that would require them to be outside. For those with livestock or outdoor pets, make sure animals have shelter from the wind and adequate bedding. Water sources need to be checked frequently because they can freeze. Increase feed for livestock during extreme cold because they burn more calories to stay warm. For late January, it's too early for specific preparations, but it's not too early to think ahead. If you use prescription medications, make sure you want to run out. If a winter storm hits, pharmacies might be difficult to reach. Stock up on non-perishable food. Not because you will be snowed in for weeks, but because it's easier to stay home than to drive in bad weather. Make sure you have batteries and flashlights in case of power outages. Ice accumulation on power lines can cause outages. Now let's address a question I often see. Why has this winter been so mild in many areas? The pattern has been dominated by the polar jet stream rather than the subtropical jet stream. The polar jet has been fairly progressive, meaning systems move through quickly without much development, and the position of high-pressure ridges has prevented sustained cold air from reaching much of the lower 48. In the west, particularly the northern Rockies and the Pacific Northwest, persistent high pressure has led to above normal temperatures and below normal precipitation. Some areas are seeing significant snow deficits. This has implications for water supply later in the year, particularly in areas that depend on snowmelt for water. In the east, we've had brief shots of cold air followed by warmth. That back-and-forth pattern is hard on people. Temperature swings cause sinus issues, headaches, and other health problems. Some areas have seen more illness this winter because immune systems are stressed by constant temperature changes. But patterns do change, and we're seeing signs of change now. The question many of you have is, will we get snow? For those in the northern tier states, from Montana across to Maine, snow is very likely at various points over the next 2 to 3 weeks. The question is, how much and exactly when? For those in the Ohio Valley, the Mid-Atlantic, and the interior Northeast, snow is likely, but the amounts and timing depend on how systems develop. The late January pattern looks more favorable than what we have seen so far this winter. For those in the South, from Texas through the Gulf Coast and into the Carolinas and Georgia, significant snow is less likely. You'll see colder temperatures. You might see some snow showers or light accumulations, particularly in the Appalachians or in areas north of Interstate 20. But major snowstorms in places like Atlanta, Birmingham, or New Orleans are not suggested by current model guidance. I know that's disappointing for some of you, but it's the reality based on the pattern we are seeing. One thing I want to emphasize, forecasts change. What I am telling you today is based on the information available today. Models will update, new data will come in, the forecast for late January will likely change multiple times between now and then. Some changes will be small, some might be significant. That is why it is important to check forecasts regularly, especially as we get closer to potential weather events. Temps rely on a forecast from a week ago. Conditions change. Models improve as we get closer to an event. Another thing I want to emphasize, be cautious about over-interpreting single model runs. I see this all the time on social media. Someone posts a screen grab from one model run showing a huge snowstorm 10 days out. People get excited or worried. Then the next model run is completely different, and people get whiplash. Single model runs are just that, single data points. What matters is the trend across multiple runs and multiple models. What matters is the ensemble guidance. If you see one outlier run showing something extreme, don't assume it's going to happen. It might, but it is more likely that the consensus solution is closer to reality. Let me give you an example. Earlier this season, there was a model run suggesting a major nor'easter for the Mid-Atlantic and Northeast. One run, the ensemble members didn't support it. Other models didn't show it. Yet, it got a lot of attention on social media. That storm never materialized because it was an outlier solution, not a consensus solution. Conversely, when multiple models and multiple ensemble members consistently show a pattern or event, confidence increases. That doesn't mean it's guaranteed, but it means the probability is higher. For this weekend's Arctic blast, we have high confidence because the signal is strong and consistent across models. For late January winter weather potential, we have moderate confidence because the pattern looks favorable, but details are still uncertain. That is how you should think about forecasts, in terms of probability and confidence, not certainties. Let's talk briefly about climate versus weather. I know this comes up, especially during extreme weather. Weather is what's happening now or in the short term. Today it's snowing, tomorrow it will be cold. That's weather. Climate is the long-term average of weather conditions. Climate tells us what's typical for a given location at a given time of year. Climate tells us that January in Chicago is normally cold and snowy. Climate tells us that July in Phoenix is normally hot and dry. Individual weather events don't prove or disprove climate trends. One cold week doesn't disprove warming trends. One warm winter doesn't prove warming trends. You have to look at data over decades to see climate trends. That said, there is evidence that the jet stream patterns are changing. The Arctic is warming faster than lower latitudes. That reduces the temperature gradient between the Arctic and the mid-latitudes. The jet stream is driven in part by that temperature gradient. When the gradient weakens, the jet stream can become more wavy and more prone to blocking patterns. Some research suggests this can lead to more persistent weather patterns, both warm and cold, a ridge that sets up and stays in place for weeks, a trough that brings cold air and refuses to move. That's one hypothesis for why we sometimes see extended periods of unusual weather. But the science is still developing, and regardless of the underlying causes, we still need to forecast and prepare for the weather we're going to get. So, To summarize the forecast, over the next several days, lake-effect snow will impact areas downwind of the Great Lakes. Heaviest totals in western lower Michigan, northwest Indiana, the Tug Hill Plateau in New York, and areas downwind of Lake Erie. Localized amounts of 12 to 18 inches possible in the most persistent bands. Thursday, a weak system brings snow showers as far south as parts of North Carolina and Virginia. No significant accumulations expected, but it shows how far south the cold air will push. This weekend, particularly Sunday, a significant Arctic blast arrives. Temperatures 20 to 25 degrees below normal across the Midwest and Great Lakes. Wind chills below zero across a wide area, dangerous cold for anyone without adequate shelter or preparation. Early next week, the cold persists across the northern states. The Gulf Coast sees cooler than normal temperatures, but not extreme cold. Late January, roughly January 24th through 31st, the pattern looks favorable for winter weather across the Central Plains, Ohio Valley, Midwest, Mid-Atlantic, and Northeast. Specific details are uncertain at this range, but the overall setup suggests the possibility of accumulating snow events. That's the forecast based on current model guidance and atmospheric conditions. Stay informed, check forecasts daily, prepare appropriately for the weather that's coming to your area. Take care of yourself and your neighbors, especially those who are vulnerable. And remember, winter weather is part of living in the northern United States and Canada. It is January. Cold and snow are normal for this time of year in many areas. We prepare, we adapt.